Let's have the solution to example 78 about space trusses. This is the first. The truss shown consists of six members and is supported by a ball and socket at B. Short link at C and two short links at D. Determine the force in each of the members for P equals negative 2184 newtons J and Q is 0. So we have Q is 0, P is 2184 downward, and we anticipate reaction components at C to be just one because they have only one short link. At B we have dy, at D we have dy and dx. At B we have three reaction components, bx, by, and bz. So first let's determine the support reaction at C by summing up moment about bz equals 0. So all forces at B and D will not be involved. So only Cy and 2184. By right thumb rule, this is the positive sense of moment. So therefore, we have Cy times 2.8 equals 2184 times 0.8. So Cy times 2.8 equals 2184 times 0.8. So computing for Cy is 624 newtons. Then we put the forces at C. So we have FAC, FCD, and FBC. So we write FAC in vector form so that we can easily determine the components. So FAC is along X, it's negative 2i. FAC rather, or CA, FAC, I just call it FAC. So it is negative 2i along X, upward 4.8, so positive 4.8J, then 0K. So there's no movement along Z. Divided by this distance, so square root of 2 square plus 4.8 square. Simplifying, FAC is magnitude of FAC, negative 5i plus 12J over 13. Then FBC is negative 2.8i and positive 2.1k, 0j. So divide by distance, square root of 2.8 square plus 2.1 square. So FBC is equal to magnitude of FBC, negative 0.8i plus 0.6k. FCD, on the other hand, is negative 2.8i then positive 2.1k divided by square root of 2.8 square plus 2.1 square. There's no movement vertically, so 0j. So it's the same, negative 0.8i, FCD negative 0.8i, then negative 0.6k. So first at C, summation forces Y equals 0. So vertical component of FAC is 12 over 13 FAC plus CY, which is 624. So 12 over 13 FAC plus 624 equals 0. From there, we can compute FAC, which is negative, or FAC is in compression. So FAC is negative 676 newtons, or FAC is 676 newtons compression. Then sa summation forces X equals 0 and summation forces along Z equals 0. First, summation forces along X equals 0. So X component of FBC is negative 0.8 FBC. X component of FCD is also negative 0.8 FCD. Then X component of FAC is FAC times negative 5 over 13, or negative 5 over 13 times FAC. But FAC is negative 676 equals 0. Simplifying, 0.8 FBC plus 0.8 FCD equals 260. Call this equation 1. Then summation forces along Z equals 0 at C. So we have FBC times Z component of FBC is 0.6 FBC, then plus Z component of FCD, negative 0.6 FCD, then equals 0. There's no component for FAC. So equation 2, solving equations 1 and 2 simultaneously allows us to compute FBC, which is equal to FCD. They are equal 162.5 Newton. So of course, we anticipate that they are equal because of symmetry. So likewise, we also conclude that the force in AB and in AD would also be the same. So having found these two forces, we compute Dy by summing up moment about dx equals 0. So by right thumb rule, positive moment would be in that direction, in that sense. So so 2184 times 2.1 equals By times 4.2. So solving for plus Cy plus Cy times 2.1. I almost forgot. There is Cy here. So equals Cy times 2.1. Solving for By is equal to 780 newtons, which is also expected to be equal to dy by symmetry. So if you sum up moment about dx equals 0, the equation would have been dy times 4.2, just like this, dy times 4.2, and plus 624 times 2.1 equals 2184 times 2.1. So it's the same. That's why by and dy are equal. Then let's solve for bx. To solve for bx, we sum up moment about dy equals 0. These are the forces. Summation forces along z equals 0 first. So since there's no other there's no other force in the z direction except bz, so bz is 0. So bz plus nothing equals 0, so bz is 0. Then summation moment about dy equals 0. So right thumb rule, so this is the positive sense. Bx times 4.2. Bz passes through dy, so it's not involved. And all other forces are vertical, parallel to the y-axis. Therefore, bx times 4.2 equals 0. So that means bx is 0. So if dx is 0, summation forces along x, because this is 0, dx will also be 0. So that's why bx equals dx equals 0. Then at b, summation forces y. By the way, FAB in vector form is magnitude of FAB. Then it is supposedly FBA, but I just call it FAB. It is directed up to the right. So up to the right and backward. So to the right, 0.8i along x. Upward, 4.8, so 4.8j. Then backward by 2.1, so negative 2.1k over distance square root of 0.8 square plus 4.8 square plus 2.1 square. So FAB simplifying is FAB, magnitude of FAB 8i plus 48j plus 21k over 53. Then we already found FBC and we already wrote that in vector form. So therefore, summation forces along y at b equals 0. We can now compute FAB, which is expected to be the same as FAD. So vertical component of FAB is 48 over 53 FAB, and plus BY, and BY is equal to 780 equals 0. So solving for FAB, FAB is negative. It is equal to FAD also, negative 861.25 newtons. So therefore, FAB equals FAD equals 861.25 newtons compression. Then finally, summation forces along Z equals 0. We have BZ0, remember? So negative of FBD, because it is backward, then Z component of FAB is 21 over 53 times negative 861.25. Then the Z component of FBC, which is in that direction, FBC is this one, zero point 0.6 of FBC, and FBC is 162. So 162.5 times zero point 0.6 equals 0. So solving for FBD, FBD is 243.75. So that's it. The member forces are completely found. So that's the solution to this problem. If you wish, you want to check joint A, then just do it. Anyway, we have verified that the answers are correct. So we have the solution to problem 79. The truss shown consists of 9 members and is supported by a ball and socket at B, a short link at C, so one unknown here, one reaction component, and 2 short links at D, so 2 reaction components at D. Determine the force in each member. For P is negative 1,200, so this is downward, and Q is 0. So we expect only one reaction component at C, 3 reaction components at B because it is a ball socket joint. So the vertical reaction call at By, dy at D, then Vx, Vz, and at D we have dz. So let's determine if this space truss is determinate. So there are 1, 2, 3, 4, 5, 6 reaction components, and members 1, 2, 3, 4, 5, 6, 7, 8, 9. So 6 plus 9 is 15. R plus number of bars is 15. And 15 is equal to 3 times number of joints. Because in each joint, we can write 3 equations of statics. So 3 times 5 is also 15. Therefore, the truss is determinate. And if you look at the figure, it is stable. Now, we can find a joint where there are 4 meeting members. And in these meeting members, 3 members are on the same plane. Since these 3 forces are on the same plane, the one that is oblique to that plane carries no force. So therefore, we found force in AE to be 0. So Q is 0, P is 1,200 downward, and the force in member AE is 0. So let's solve for By by summing up moment along dz about dz equals 0. So by right thumb rule, this is your right thumb in that direction, so the 4 fingers would curl in that way. So 1,200 times 1.2 equals By times 1.8. So that would be the equation. BZ is parallel, BX passes through DZ axis. So these two forces have no moments about DZ. So solving for By is 800 newtons. Summation forces along X equals 0. Since there's no other load that is in the X direction, we conclude that Bx is 0. Then summation of moment about dy equals 0. To solve for Bz's example, so this is dy axis. The positive sense of moment will be this. So Bz is negative. So negative Bz times 1.8, supposedly plus Bx times 3, but because Bx is 0, so it's not involved. Therefore, Bz is 0. So negative Bz times 1.8, supposedly plus Bx, which is 0 times 3, but Bx is 0. So there's no more equation equals 0. So that means Bz is 0. Now, if Bz is 0, summation forces along Z, dz is also 0. So that's why bz equals dz equals 0. So at joint B, let's put the forces. So we have FAB, FBE, and FBC. So only FAB is inclined. Let's write the vector form of FAB to determine its components. So magnitude of FAB, it is directed rightward 0.6i, upward 3j, then backward 0.75, so minus 0.75k, over square root of 0.6 square plus 3 square plus 0.75 square. Simplifying, FAB is magnitude of FAB 4i plus 20j minus 5k over 21. So summation forces y equals 0 at B. Then we have vertical component of FAB, which is 20 over 21 FAB, plus BY, which is 800, equals 0. So we can now solve FAB. It is negative 840, so FAB is 840 newtons compression. Then we sum up forces along X equals 0. Take note BX is 0. So FBC, positive, plus X component of FAB. The X component of FAB is FAB, which is negative 840 times 4 over 21. So FBC plus negative 840 times 4 over 21 equals 0. So FBC is 160 newtons tension. And summation forces along Z at B equals 0. So take note FBE is assumed to be in the negative direction. So negative FBE, then plus BZ, but BZ is 0, plus the Z component of FAB, which is FAB times negative 5 over 21. This is FAB, and we have negative 5 over 21, the force multiplier, or yes, negative 5 over 21 of FAB equals 0. So FBE is tension, 200 newtons tension. We then compute CY by summing up moment about dx equals 0. So by right thumb rule, this is the right thumb, so this is the positive sense, that way. So 1200 times 2.25 equals CY times 3 plus BY times 3. So CY times 3 plus BY is 800 times 3. So solving for CY is equal to 100 newtons. Having found CY, then we put the forces at C. Let's level them. So let's write FAC in vector form. FAC is from C to A, so negative 1.2i, positive 3j, then negative 0.75k. Negative 1.2i plus positive 3j, negative 0.75k, over distance square root of 1.2 square plus 3 square plus 0.75 square. Simplifying, FAC is magnitude of FAC times negative 0.3618i plus 0.9044j minus 0.2261k. FCE in vector form is negative 1.8i, 0j, then negative 3k, divided by square root of 1.8 square plus 3 square, plus 0 square plus 3 square. So simplifying, FCE is FCE quantity negative 0.5145i, then negative 0.8575k. So summation forces along Y equals 0 at C to solve for FAC. So vertical component of FAC is FAC times 0.9044 or 0.9044 FAC plus CY, which is 100, equals 0. So 0.944 FAC plus 100 equals 0. Solving for FAC, FAC is negative 110.57. Negative value means compression. So 110.57 newtons compression. That's FAC. Then summation forces along X equals 0. So the X component of FCE is negative 0.5145 FCE plus the X component of FAC, which is negative 110.57 times negative 0.3618, then plus FB minus FBC, which is 160. So again, X component of FCE is negative 0.5145 FCE, then minus 160, which is FBC, this one, going to the left. Then the X component of FAC is negative 110.57 times negative 0.3618, negative 0.3618 times negative 110.57 equals 0. So solving for FCE, FCE is negative 233.23 newtons, so FCE is 233.23 newtons compression. Then to solve for FCD, summation forces along Z equals 0. So FCD is assumed to be in that direction, tension, so it is in the opposite direction, so negative FCD. Then negative point, the Z component of FAC is negative 0.2261 of FAC, so negative 0.2261, this is FAC. Then the Z component of FCE is negative 0.8575 of FCE. So negative 0.8575 of FCE, and FCE is negative 233.23 equals 0. Solving for FCD, FCD is positive 225 Newton. So it is tension. Now for the remaining forces, let's have it on the next slide. So let's continue. So we now proceed to compute dy. So summation of moment, these are the unknown forces, and FCD was found in the preceding slide, 225 newtons. Summation moment about Bx equals 0 to solve for dz. So by right thumb rule, the curling of the forefinger should be this. So it is dy times 3, then equals 1,200 times 0.75. So dy times 3 equals 1,200 times 0.75. So dy is 300 newtons. So there's a need to express FAD in vector form. FAD is negative 1.2i, positive 3j, then positive 2.25. So that's A. So positive 2.25k over distance, square root of 1.2 square plus 3 square plus 2.25 square. Simplifying, FAD in vector form is magnitude of FAD times negative 0.3048i plus 0.7619j plus 0.5715k. So only FAD must be in vector form. The rest, it's directed. FDE is in the negative x direction, and 225 is in the positive z direction. So at the summation forces y equals 0, vertical component of FAD is 0.7619 FAD plus dy, which is 300, equals 0. So solving for FAD, FAD is negative, and negative means compression. So 393.75 newtons compression. Then summation forces along x equals 0 at D. So FDE is negative, so negative FDE. Then x component of FAD is negative 393.75 times negative 0.3048, or negative 0.3048 times negative 393.75, represented by this, equals 0. So FDE is positive 120.0 newtons. So I think everything is found. So all we have to do is check if joint A is in equilibrium. So summation forces x, let's recall FAB. This FAB was negative 840. FEC was negative 110.57. 57. Of course, FAE is 0 and FAD is negative 393.75. So this was the expression for FAB. Then FAC is this FAC quantity, negative 0.3618I plus 0.9044J minus 0.2261K. Then FAD, of course, is this one. So summation versus X is equal to negative 840 times 4 over 21. This is negative 840 times 4 over 21. Then plus 0.9044 of negative 110 point, sorry, FAD negative, FAC negative 0.3618 of FAC, which is negative 110.57. Then FAD is negative 0.3048 times negative 393.75. So computing this value, it is almost 0. So therefore, summation versus X at joint A is almost 0. So it is in equilibrium along X. Summation versus Y. So take note that AB is upward, but BA is upward. We represent AB to be from B to A upward, but this time AB is downward. So let's consider downward as positive. So negative 840 times 20 over 21. So 1,200 must be treated positive. Then negative 110.57 AC times 0.9044 times negative 110.57. Then 0.5715, sorry, 0.7619 rather, Y component of FAD, which is negative 393.75, then plus 1,200 equals 0. Or check if it is 0. So summation versus Y is almost 0, therefore vertically joint A is also in equilibrium. Finally, summation forces along Z is equal to the Z component of FAB is FAB negative 840 times negative 5 over 21. Then the Z component of FAC is negative 0.2261 times FAC, which is negative 110.57 times negative 0.2261. Then the Z component of FAD is 0.5715 of negative 393.75. So that's it. Computing summation forces along Z is also almost 0. Therefore, since joint A is in equilibrium, all our answers are definitely correct. So that's it for this problem. I hope that you were able to follow the solution, and I explained and solved it in more detail and with detailed explanation so that you can follow.